Welcome to IgentForm program. In this short film I will show how to define a supporting structure for chimneys and how to export this model to Autodesk Robot Structural Analysis program. Let's start from definition of some default materials. Here I set steel for beams and diagrids. In IgentForm, the whole structure consists of masses. For each mass, we should define a contour. So next step in our project is contours definition. First, I define contour for supporting structure, rectangle 5 × 5 meter. There will be a few platforms in the model, so I choose rectangle 7 × 7 for them. I plan to define 4 chimneys with advanced shape, so I define a contour 1.4 × 6.4 for a mass, which will help me to create curved part of the chimney. The chimney diameter will be 1.6 meter, and I also define steel profile for supporting structure columns. So let's start to parameterize supporting structure. First, I assign previously defined steel sections to corner columns. In IgentForm, it is also possible to parameterize default spread footings. Here, I switch off the pier and modify footing dimensions. Next, I assign steel as corner columns material, and columns color is changed according to material settings. It is also possible to assign different colors for different sections created from the same material. Now I set mass height and number of stories. By default, program automatically switch on upper slab and middle slabs, but here we don't need them, so I switch them off. For lower part of supporting structure, I will use another mass with settings copied from previous one. I change its height, I set number of stories to 1, and I position this mass in relation to previously defined one. I use for it an option vertical alignment, and I choose bottom down type. Now, quite difficult task, curved part of chimneys definition. So I define new mass and I assign to it contour defined at the beginning. I assign circular sections with diameter 1.6 meter. To get a curve, I switch off simple prism option and I switch on curve generatrix option. It means that now I have a possibility to form side walls of mass according to predefined or user-defined shapes. I choose the second type of curve projection. Program automatically filters all curves from database, which can be used for this option. After changing the scale of upper contour, chosen curve automatically adjusts to mass shape, taking into account mass height and dimension difference of upper and lower contours. As there will be 4 chimneys, and each chimney curved part will be rotated in relation to previous one, here I leave chimneys in 2 corners. I profit from the possibility to switch on or off corner columns in any corner. Next, I change mass name for clarity and I copy it with the whole structure. Now it is sufficient to rotate the whole mass by 90 degrees to get curved columns in proper horizontal locations. Finally, I select both masses and change the Z coordinate to get them in proper vertical locations. Now let's define vertical part of chimneys. It can be done in many ways. Here I simply copy previous mass, I set its type as simple prism and change its height. Now I position it vertically above curved part of chimneys and I make horizontal alignment with equal dimensions option. This means that upper mass contour will be the same as lower mass upper contour, so I get an effect that chimneys part are connected. As previously, after mass copying and rotating it, I have 4 vertical parts of chimneys. On a 3D view we can see that something is wrong. Rotation angle of one mass has been changed by mistake. It is not a big problem in IgentForm. As structure is online visualized on 3D view, such problems can be noticed at once. In every moment, we can easily find and select appropriate mass and error place and correct it. Let's go further. Our model, due to large sections of chimneys, is not very typical from structural point of view. we would like to somehow connect chimneys with supporting structure and still have model in access. I will try to use short beams for this purpose. It is an occasion to show another IntelForm option, access and internal lines definition for contour. We can define X or Y axes in any point and adjust their positions. To choose axis direction, one should click on any axis endpoint. If now I increase number of axes, program will add them in the same direction after selected axis. When axes are generated, we can define internal lines simply by clicking intersection points. Such internal lines can be later parameterized as contour lines. Additionally, internal lines have one unique feature, namely, they are logically connected with axes. So if the user changes axis position, internal lines and all structural elements which are defined on them are automatically moved to new location. Here I selected all contour lines and all defined internal lines, and I switch on beams on them. In IntelForm, it is possible to view design structure from different perspectives. The user can easily set required projection, for example XY, and verify the model. In comparison to traditional modeling, parametric modeling seems to be more flexible. We need only to change the way how we look at the structure and see it as a set of logically connected intelligent forms instead of set of messy elements. If we would like, for example, to have diagrids in some part of the structure, we simply switch them on the required lines. After setting the number, section and type, diagrids are automatically added for the whole mass. Now I would like to demonstrate another useful IntelForm option, namely possibility to add a substructure to currently defined model. It is still according to the just expressed idea that we try to create our model from blocks which can be independently parameterized. So such substructure can consist of any number of masses. In my example, I need to define a support structure for chimneys. I defined it previously as a separate file in standard IntelForm format, and now I can import it to my project. I simply open the file without deleting existing structure. As my substructure has been defined in the middle of coordinate system, in this project I need to move it to proper position. So I change X and Y mass coordinates to move it to proper location horizontally. In my case, supporting columns are not symmetrical, so I need also to rotate this supporting structure to get columns in the right places. As we have 4 chimneys in the model, I will repeat this operation 3 times, adjusting imported substructure to current chimney position. Of course, it can be done in many ways. For example, we may want to save as a substructure not only the chimney support, but also chimney itself. It is not a problem, it is only an imagination of the designer to see the repeating objects. As it is not a time-consuming task, I have nearly finished. I open my substructure for the last time. I select all masses from which this substructure is composed, and I change its position and verify rotation. The coordinates must be prepared earlier to avoid later problems, as for the moment IntelForm doesn't verify if the model is really correct from calculation point of view. This verification will be finally done in Autodesk Robot Structural Analysis program. In case of problems, model can be easily corrected and exported once more. The last operation for chimney supports. I select all masses which were used to support chimneys, and I change the Z coordinate. All these masses are moved to proper vertical position. By switching off sections visibility and switching on structure visibility, I can see calculation model which is automatically created after each modification. Here I would like to pay your attention to the fact that in IntelliForm foundations are created automatically on the columns or walls at the lowest mass level, if any other mass doesn't exist below. Sometimes, like in this example, some foundations are redundant and we want to get rid of them. We can simply do it by definition of dummy mass at the appropriate place, without any structural elements. So, we use already known mechanism of mass definition, but for different purpose. Here, thanks to it, foundations which were automatically created at Chimneys ends have been parametrically deleted. At any time, for clarity purposes, we can change mass name. Program automatically checks if this name is used in other places of the program, for example as a cutting mass, and updates these references. Now the last step in our project. Let's imagine that we would like to have some platforms around supporting structure. So as usual, the best way is to define a new mass. I assigned to it a rectangle contour defined at the beginning, 7 × 7 meter. I leave only upper slab switch on, so mass height is not important here. I change mass thickness and material. Also, I set appropriate vertical location. To finish platform parametrization, short repetition from access and internal lines definition. As I previously defined them for supporting structure contour, now I do it for platform contour. Quick definition of 4 axes at appropriate positions, and we can define required internal lines. Here I define 8 lines at mass corners. For the record, if we will later move axes, internal lines connected to them with all defined structural elements will be moved also. In one mass, we can make a multi-selection of contour lines and internal lines at one time. Here I use this possibility to set beams for all these lines. I set appropriate section for them and platform parametrization is finished. On tree review, we can easily verify if the achieved effect is consistent with our intentions. Then we can just copy this platform to another locations. If I would like to change later some of original platform parameters, it would be more convenient to explicitly define these copied masses as copies of original mass using an option mass copy in basic shape group. Then they would automatically follow all changes in original mass. And finally, the last operation in our model. I select all platform masses and I cut them to supporting structure mass. So in about 13 minutes our structure is ready. Now, to be sure that model is correct, I will export it to Autodesk Robot Structural Analysis program. First I save my model in native IntelliForm format, then I choose a name of RTD file. Export is done by the use of dedicated API interface. IntelliForm supports also other formats like DXF, IFC or OBJ. Thanks to it, model created in IntelliForm can be easily exchanged with other commonly used programs. Model exported in RTD format is calculation model, so after opening it in Autodesk Robot Structural Analysis, it is generally ready for calculations. Now we are in Autodesk Robot Structural Analysis environment. I open RTD file, which has been just saved by IntelliForm program. I switch on visibility of sections to be sure that they are correctly assigned. Finally, I successfully run calculations. I encourage you to subscribe IntelliForm film channel, where you can see how different types of structures can be designed using parametric approach. Thank you very much for your attention.